All right, hello everyone. Mr. T here. This lesson number 46 is actually going to be a review lesson based on the feedback from some of y'all. Thought it would be good to take a moment and pause and review some of the concepts we learned after spring break. And so that is what this lesson will be. A couple of announcements before that. Number one, grades have been posted. I posted them on Google Classroom. This Thursday is the last day of the 6 weeks, the fifth 6 weeks. This Thursday is the last day. And so what that means is that if you have any missing assignments or anything that you would like to redo, you have until Thursday to turn them in to me. If you're good with your grade, then what is posted there on PowerSchool, what I posted on Google Classroom for those who don't have access to PowerSchool, that will be your grade for this fifth 6 weeks. If you're good with that, you have nothing that you need to do. The work for this week, as I always do, the work this week is going to go into the following 6 weeks, not into this 6 weeks. So whatever is in PowerSchool is completely updated. That is including all of your grades for this 6 weeks. We will not have a test this 6 weeks. I didn't think it would be fair to have a test online. So what I'll for the test category, I'll probably just end up just putting whatever your average is at the end of the 6 weeks, or I'll just leave it blank. So again, your grades that are posted are going to be your grades for this fifth 6 weeks, but you have until Thursday if you're not happy with it and you want to turn in any missing assignments or any redos. The way you would go about that is you would just send me a remind message or an email with what exactly you would like to do if you're missing anything. And then I'll just reply to you via email with an attachment of the assignment that you need. And then you just, when you finish, take a picture of it and send it to me and I'll update your grade. All right. I decided to give y'all a little bit of a lighter week this week, so we're just going to have this one video and one assignment on Google Classroom that will be due on Thursday to give you a little bit of a break, and then you have a 4-day weekend after that. You have Friday off and Monday off, and I hope that y'all enjoy that. And that's kind of just a heads up on a couple of announcements here, all right? So for today's review, so overall for the fifth 6 weeks, generally when we finish the 6 weeks, we have a review and then we have a test, right? And so I'm going to do 2 reviews. This will be review number 1. This one will be primarily reviewing what we learned online, which is these topics of the 6 weeks. So note 42, note 43, note 44, note 45. I'm going to review those in this lesson. And then the following lesson, I'm giving you a little bit of a break here this week, so that it'll be next week. We're going to be reviewing these, which is what we learned when we were together in person before the spring break. So this will be review 1. We'll be reviewing specifically the notes on basically solving logs and solving exponentials, because that's what we did on our online lessons and inverses. Okay, so just heads up, that's where we're headed for the lesson for today. So always start with the 4 goals. We will learn math, build character, never give up, and ask why. All right. So I thought kind of a good way to review would be to actually go over the quizzes, most commonly missed questions. And so I'm going to go over the 5 most commonly missed questions from the first quizzes, which is on solving logs and exponentials. Then I'm going to go over the 5 commonly missed questions from the second quizzes, which was on inverses as well as from solving. On the first quiz, we had an 81 average score. And so I'm gonna pull up the first 5 most commonly missed ones, and this also allows you a chance to get some feedback if you had some misconceptions on these. All right. So the first commonly missed question was the question: what is the range of the function shown below? And if we think about range is all of the y values. So we're looking at left to right. Or I'm sorry, not left to right. Lowest to highest. I'm sorry. Lowest to highest. When we're talking about range, we're looking at lowest to highest. If we were talking about domain, then we would be talking about the x values, and we would be talking about left to right. Okay, so since we're talking about the range and the y values, we're looking at lowest to highest. So we're looking at where does this graph start as the lowest value. Because this is an exponential graph, it has an asymptote right here, which means it's never going to go below 0. So the lowest is 0, that's the lowest, 0, and the highest, it goes up forever, so the highest is infinity. And we're not going to include 0 because there's an asymptote there, so it doesn't equal, it gets really close to but doesn't cross 0. So it would be from 0 to infinity, and I would put a parentheses here to represent the fact that it doesn't equal. If it was a bracket and 0, that would mean there was a point at 0, but there is not, so we use a parentheses. And then in inequality notation, what they used here was y is greater than 0, no line under it because it is only above, it's not equal to. So that's why this one would be C. A lot of us said all real numbers. All real numbers would be the range. I'm sorry, the domain. Because domain is x values from left to right. And if you look at this, this goes to the left forever slowly, and it goes to the right forever. So the domain would be all real numbers. But the question is asking for the range. That's why it would be y is greater than 0. All right, so that was the first commonly missed question. Based on that, I want you to try this one because this one is similar. It says describe the domain of the function below. So now that we know domain is left to right, range is lowest to highest, you're not including the asymptote, think about what this one would be. All right, so what you should have noticed is that log have a vertical asymptote. So one thing to know, exponentials always are like that. They always have a horizontal asymptote, that's exponential. Log is like this, and it always has a vertical asymptote, okay? So because it's a log, it has a vertical asymptote, and it's at -1. And we're talking about domain, so now we're talking about left to right. So on the left, it starts at -1, and it doesn't equal -1, it's parentheses because there's an asymptote there. And on the right side, it goes to infinity. And so the domain is from -1 to infinity. So B would be the correct answer. And a lot of y'all said A, or not a lot of y'all, but some of y'all said A. Who got it wrong? That was the most commonly missed choice. And that would be the range of this, because the lowest is infinity and the highest the lowest is -infinity and the highest is infinity. That would be the range, not the domain there. Okay? All right. This was another one from the first quizzes. So this one kind of cropped out the question. The question is which equation matches this graph? And if you look at it, you have different bases. You have two of them have a base of 4, and two of them that have a base of 1/4. And all of these equations in our answer choices are exponential because we have a base and then we have an exponent, a base, an exponent, a base, and exponent, right? So these are all exponential. So generally they're shaped like that with an asymptote that is horizontal. Now, what you have to remember on this one is when the base is a fraction, what does that mean? And when the base is a whole number, what does that mean? So in both of these cases where the base is a whole number, that means that it is increasing. Okay? And its original form, before we talk about transformation, it's just 4 to the power of x, it's increasing. When the base is a fraction, that means that it is decreasing. Base is a fraction, it is decreasing. Okay? So just based off of the fact that looking at this particular graph, it is increasing, based off of that, we know we could cross out D. Because D is decreasing, okay? We can't cross out A yet because there's a negative in that. That's going to do something we'll talk about in a minute. But right now, we're just going to cross out D because there's no negative, so nothing flipped, okay? It just moved down. All right, so now B, let's start with B. B says it's 4 to the power x and then -2. Now, obviously, if we had a calculator, we could graph all these answer choices and see which one matches. That would be a way. But I want us to do this without the calculator. So let's look at B. B says 4 to the power of x -2. So it is increasing, and because the base is 4, our original one would have a first point of 1, 4. 1, 4. Before any transformations, just 4 to the power x would have a point of 1, 4, because if you plug in 1 for x, it will give you 4. And so, and it always has a horizontal asymptote at 0, the original parent function. So it looks something like that. That's 4 to the power of x graphed. And then this -2 in B means that it moved down 2. And so if you look at the graph, this asymptote moved down 2. And so it is likely that the answer would be B. But let's look at which the answer is B, but let's look at why is C and D incorrect. Okay? C and A, I'm sorry. We already said D was incorrect. So let's look at A. So we said because it's a fraction is going down. So the original is going down. And now because the base is 1/4, the first point would be 1, comma 1/4. And it's going down. This is just a rough sketch. It doesn't have to be perfect. We're just trying to compare. This negative out front is a reflection across the x-axis because the negative is in front. So that's going to flip it over the x-axis, so then it's going to be going down like that. That's a reflection across the x-axis. That does not going to anywhere make it look like the graph that we have. So that's why it can't be A. Okay? Now, the other one we had was C. Similar idea. We have 4 to the power of x, so that was that original one. And then this negative is a reflection over the x-axis, so it's going to flip it over this x-axis, and it's going to be like that. And that also doesn't match, so that's why it would be B. Okay. So the main choice that wrong choice that was chosen was D, and that was just needing to identify that 1/4 base means that it's going to be going down, decreasing instead of increasing. Okay. All right, this is another one. So this is a question where you're trying to solve for x, and you have to think about what product or what property you'll be using to solve this log. So when you have a plus sign, we're using the product property, which is where you multiply these two since the two logs have the same base. So this be written as log base 7 of x plus 1 times x minus 5 equals 1. Because we're multiplying these, we're going to FOIL this, or box method, so that's going to be x squared minus 5x plus 1x minus 5. That's that FOIL. We have log base 7. I'm just bringing these two down. We can go ahead and combine these like terms right here. That's going to be negative 4x and bring everything else down. So I'm bring down the x squared, bring down the minus 5, bring down the log base 7, bring down the 1. Okay. When I was looking at some of y'all's work, one thing I was noticing is that some of us were multiplying these two sometimes, like in regular practice, and then we weren't bringing down the log. So you always want to bring down the log also, because at this step right here, you want to rewrite it in exponential. 7 to the power of 1 equals what's in parentheses there, right? Like a circle. And then you go from there. 7 to the power 1, 7. Then you move the 7 over. So you can, because I have a quadratic, we know we need a factor. It's going to be minus 12. And then you just factor this using the x method. Negative 12 goes at the top because your a is 1, your c is negative 12. A times c, 1 times negative 12, negative 12. B goes at the bottom, your b is negative 4. So you're looking for two numbers that multiply to give you negative 12 and add up to give you negative 4. And that would be negative 6 and positive 2. And then you divide by your a, which is 1. And so you get x minus 6 and x plus 2. And since you're setting it equal to 0, you are doing the opposite. And so when you solve this, this will give you x equals 6, and this will give you x equals negative 2. So if you look at the answer choices, you see only 6. You see 6 and negative 2. We can cross out 3. That doesn't really match with anything. And then we have no solution. No solution would be the case if both of these are false when you plug it in. 6 would be the case if only 6 is true when you plug it in. 6 and negative 2 would be the case if both of them are true when you plug it in. This is where you need to go back and you need to check if it's true or false. Okay. Some of y'all were asking me how would I do this checking part in the calculator if I have access to a calculator. And I'll show you that for those who are asking. All you would really do is you would just take this 6 and you would plug it in for x and you would type in the whole statement as it is. So I have an Inspire here because that's what I just downloaded it, and there's a free 6 months Inspire if you have access to an iPad or a device that, or a laptop or something that allows you to download the Inspire app. I think I sent that link. 6 plus 1. So I'm just typing it in. Plus log base 7. Just of, instead of x, I'm putting 6 minus 5. And then I'll put equals 1. So I'll just type in the statement exactly as it is. And that is true. So that means 6 is true. Now, if we don't have access to a calculator in any form, then what we would do is just plug it in by hand like we've been doing. But I just wanted to answer that question for those who were asking. So you'll just plug in -2 in here. And here. Bring everything else down. And simplify. So I would do the parentheses first. That'd be -1. That would be -7. And then now right here, what you have to remember is that you can't take log of a negative number. It doesn't exist. If you try to do log base 7 of a -7, try to see what that equals. When you rewrite it in exponential, you're going to get 7 to the power x equals -7. There is no number that you can plug in here that's going to equal -7. So anytime you have a parentheses in parentheses and a log in front and is negative, it's automatically false. If you try to do the math here, it's not going to work. So that means -2 is false and 6 is true. So B is going to be our answer, only 6. Okay? All right. There's one more from that quizzes. And this one is similar. This is a log problem. So I want you to, based on what we just did with the other one, try to use a product property and solve it. Well, the answer is here. I was going to have you pause it and see, but actually I put the answer here. Never mind. You can try it and see if you got the answer that is here. But what you should have done is log, and you're going to multiply these two because it's addition. So it'll be x and then x plus 3. And distribute this. So it'd be x squared plus 3x. Be log, and that equals 1. And so once we combine these two using the product property, then we can rewrite it in exponential form. Now remember, when there's a log and there's no base here, the base is 10. And so then you're going to rewrite it. 10 to the power 1 equals that. This would be 10. And then we're going to move the 10 over so we could factor. And then we're going to do the factoring part. I'll do this part fast since we're kind of been doing this. -10, what two numbers multiply -10? Add up to 3. 5 and -2. Divide by 1. So it'll be x plus 5, x minus 2. And you can always pause and rewind at any time. That will be x equals -5, and that will be x equals 2. Now on this one, once you get your answer, and this one, quite a bit of us got right, but I want to be at that 80%. What would end up happening is that 2 would be the one that is true, and 5 would be the one that is false. And I'll just show you the quick math of 2 being true. You will have log of 2 plus log of 2 plus 3 when you plug in. This would give you log of 5. Bring that down, bring that down. Then because it's addition, you will multiply. So it'll be log. When you multiply the 2 and the 5, it'll be 10 equals 1. And that is a true statement, because when you rewrite it, the base is 10. 10 to the power of 1 does equal 10. And so this one is true for that reason. Okay? So that's the 5 most commonly missed questions on the first quizzes. I'm going to go over the second quizzes. Hopefully as we go over them, it clarifies if you missed any of these. On the second quizzes, we had a little bit of a lower score. We had a 78 average score. This one had a lot more inverses on it, and it had some of the same type of problems with the solving. The first one here, we had 51% only that got this one right. So I want to talk about this one. You're trying to solve this for x, and these are exponential. So when you have exponential, that's where you have to use the property of equality and have the same base. So if this is a base of 6 here, we want to see how can we make this have a base of 6. And we will rewrite it as 6 to the power of what? Okay, 2. And that would be, you would keep that x out there. And I'm just going to leave this one as it is. And then what you have to do is you have to multiply this. So it'll be 6 to the power of 2x, 6 to the power of 2x. And then whenever the bases are the same, you can go ahead and just set the exponents equal to each other. So 2x equals 2x. Now here might be where some of us got tripped up. We see 2x equals 2x, and we're trying to solve for x. So what you're trying to see is what number could you plug in for x that will make the statement true. Because the left side equals the right side, no matter what you do, it's going to equal the same thing. Like let's say you divide by 2 on both sides. It's going to cross out. You're going to have x equals x, right? So what ends up happening is what number could you plug in here that would equal this one? Any number, right? If you plug in 5, 5 equals 5. You plug in 6, 6 equals 6. They're the same thing, x equals x. So that means there's an infinite number of answers you could plug in for x to make it true. That's why the answer is infinite solution, because any number will work that you plug in there to make the statement true, because they're equal to each other. So anything you plug in here, the left side will equal the right side, okay? All right. This was another one. We had 63%. The question says, which graph represents the inverse of the equation? And let me write this bigger. Y equals 3 to the power x. So it's asking for the inverse of this. So first you have to think, what is this function? Is it exponential? Is it log? What is that function? Is it an exponential function or a log function? Okay. If it's an exponential function, we know that the inverse of an exponential function is a log function. So that's one way you could solve this. You can see the question asks for the inverse of an exponential, and you can just look which one is a log. Or you can actually do the math and switch x and y if you prefer. So you could switch x and y, because that's what inverse is. X and y is flips. And then this one you would just go ahead and convert it to log in order to solve for y. So it'd be log base 3 of x equals, goes like a circle, y. So you would look for, this would be your inverse, because you switched x and y and you solve for y. Which graph is the log? And this is not a log. This is an exponential. This will be your log base 3 of x. Because if you remember, your log always starts like this. It has a vertical asymptote. Your exponential goes like this, and it has a horizontal asymptote. So this one is your log base 3 of xc. Okay? All right. On this one, I want you to try this one again, because this is similar to the other commonly missed question on the other one. So what is a domain of log of x? All right, so what you should have noted is that that question is asking for domain, which is x. So that's left to right. We have an asymptote here. So if we have an asymptote, that means you are not including that value, is what I talked about earlier in the other question. So it starts at 0, but we are not including 0 because it doesn't equal 0. So we use a parentheses here, not a bracket. And then it goes to infinity on the right. So the difference between these two, this has a bracket, which would mean it actually equals it or it crosses it. This has a parentheses, which means it's not equal to. So this one would be C. Because there's an asymptote here, it doesn't cross 0 or touch it. So the kind of main differences here, where's the difference between parentheses or bracket. Okay? All right, now an inverse question. The question says find the inverse of this function, f of x equals 5 to the power of x plus 2. This is an exponential. Inverse of an exponential is a log. first thing you want to do is switch x and y. So it'd be x equals 5 to the power y plus 2. We're switching x and y first. After you switch x and y, you need to determine, is this exponential by itself, or do we have anything on the outside we need to get rid of? We don't have anything on the outside. We only have the base and the exponent. So we will go ahead and convert it to log. It will be log base 5. Let me erase this. And it goes like a circle of x equals y plus 2. Then we need to solve for y, so we're just moving this 2 over. When you move this 2 over, it's not going in parentheses. It's out here, and that's equal to y, so that is your inverse. And another way to write inverse is f negative 1 of x. So because this negative 2 is not in parentheses, we don't want to select A where it has it in parentheses. We would have B where it is outside of the parentheses. Another way you could see this answer written as is like this. Those are the same thing. If you don't have a parentheses, it is understood to only be around the first term there. Okay? This one has a parentheses, but it's not necessary here. But the answer would be B. Okay? All right, last inverse question. So this one is similar. Just ask for the inverse of this function. So first step, you switch x and y. Just wanted to do this one to make sure everybody's good with inverse. After you switch x and y, then you're looking at this and you're seeing, does this exponential have anything on the outside I want to get rid of? And it does in this case. We would need to move that first by adding 1. Okay. Now that you have the base and the exponent by itself, you convert it to log. So it'd be log base 4 of x plus 1 equals y plus 1. And we're solving for y, so we need to move this 1 over. When we move the 1 over, we can't bring it in this parentheses. So it's log base 4 of x plus 1 minus 1 on the outside equals y, or I'll change that to the inverse. And that's how you get A. Okay? So hopefully that was helpful to go over some of the commonly missed questions. I know some of us might have gotten a high grade on that, and maybe it was just a review for you. Maybe some of us, it was helpful to go over some of the questions that you missed. Hopefully that kind of clarifies or confirms the kind of concepts there. So what your practice is for this is just a 10-question practice I uploaded on Google Classroom. Is due on Thursday. The primary kind of thing I wanted you to work on this week is if you had any missing assignments. If you don't, it's kind of just a chiller week for you to kind of rest, rejuvenate in terms of, for my class, not a lot of work there, okay? So y'all have a wonderful day. Enjoy your long weekend.